Hello, everyone. My name is Bailey Cobb, and this is our team.
Monica Perez,
Joaquin Garcia.
Nicolas Camilla.
Edgar Villanueva.
So 2 semesters ago, we were approached with this challenge and project to create an unmanned surface vessel capable of obtaining an oil sample from an oil spill. A little bit of background on our project. As you all know, oil is a vital part in our actual society today, and one of the major transportation methods of this oil is by barge from port to port. Unfortunately, oil spills do occur. And as you can see, from 1970, there has been a recorded of 150 oil spills, which averages out to about 1.3 per year. And that may not seem like a lot, but with each one of these spills, it actually results in tons and tons of oil being spilt into our Gulf. And the Coast Guard is responsible for the containment and removal of this oil. One method of containment is the use of booms and barriers where they contain the spread of the oil in the ocean itself. And there are 3 options for removal. One is skimming, which is the use of specialized vessels that skim the surface of the water to relocate the oil. The second is chemical dispersants, which actually shrink the molecules of the oil themselves, which allow for a natural degrading process to happen and occur. And the third is a bioremedy, where they actually introduce microorganisms to the oil that actually consume the oil itself. And to basically pick the option that is the most effective and efficient, an oil sample is needed, and that is where our product comes into play. So the problem right now with the current sampling methods is whether that be either a submergible device or a USV, they're pretty heavy and they are pretty bulky. So to get out there, they need a tugboat that is capable of operating a mechanical lift to raise and lower these sampling methods. And with the tugboat itself, it poses risk for damaging the boat as well as displacing the water, which could result in an inaccurate reading in the oil sample. So here are some of the deliverables that we plan on delivering with our project itself. It is a fully functioning working USV that is capable of assembly and disassembly for transportation purposes, as well as a detachable frame that can also be assembled and disassembled. It can also be modified if the size is wished to be increased. Along with our product as well comes an instruction manual or video for the assembly of the boat itself, as well as a controller to drive and actually activate the sampling mechanisms. It was pretty cool. So about 2 years ago, this project was also issued to a prior senior design team, and here's their previous work. As you can see, they used laser cut wood, which was then layered with fiberglass to prevent any water leakage into the holes where the actual electrical system was placed. And with their choice of materials, it did end up making the boat pretty heavy. It's around 55 pounds without the sampling method added. So it's a little on the heavy side because it is over the OSHA regulation for 50 pounds. As well, you can see that it is detachable. The only thing detachable on this boat, though, is the frame. So whenever you take it off, it still leaves 2 major pieces that are 56 inches long, which is a little over 4.5 feet. So for transportation purposes, it's pretty hard to just put it in a container and go on. So some of our objectives with our USV is we plan to reduce the size of the previous USV, the size and the weight, by at least 30%. Fully disassembled, it should be able to fit inside of a 30 by 20 by 15 inch container, as well as obtain a speed of 10 to 15 miles per hour, as well as each hole should be able to disassemble into 4 separate pieces. And it should have enough space to hold a 5-pound sampling system that we were given by Dr. Garcia at Water Mapping. As you can see here, here's the actual sampler. So the actual sampler itself is the red object. Behind that, it will be strapped to a marine grade linear actuator, which will then lower the sampler into the water. And you can see the test tube on there. It would actually be mounted to the sampler itself. So when lowering into the water, it will fill up, and then the sensor on the back will activate whenever it hits the water, raising a rubberized cap that would be placed on the mini linear actuator to the bottom of the test tube, trapping the oil sample inside of the test tube. Now here's Joaquin to explain kind of our initial design of our USV.
So for our initial design, we decided that we needed something that was detachable. This design, for our initial design, we decided to do something with a male and female connection with a way to be able to access the wires so they can run through the entire hull without having any disturbance. In this initial design, we actually had the plan of having wires on top of it, having it covered by a plastic shield that would be able to access any required electronics while in missions. In this initial design, we can see the general idea that we wanted to follow, with the latches being on the side of the holes and being able to detach everything while keeping everything concealed and waterproof. However, with this design specifically, it became very hard to print whenever we came to whenever we came down to the actual 3D printing. So for our next design, we decided to do something a little bit easier for the 3D printing by having an entire hull be covered by the 3D printer. In this case, we would have full waterproof inside the wiring, basically. So each of the hulls would be able to have each of the required components inside of the hulls. This design actually allowed us to have our PVC frame attached to the actual design of the hulls, as you can see by the hole on the top of the design. However, this one did still have issues printing because our 3D printers did not quite fit the size that we were required. So this led us to our final design. This final iteration of our boat allows us to access the wiring using a set of lids with pegs that are able to be removed and reattached with ease. These pegs would allow the boat to be waterproof, not allowing any of the water to reach the electronics, while also having each of the pieces be individually printed that would be able to fit a Bamboo P1S printer. These pieces also still have the components for the frame to be attached at the front and the back piece. These would be attached to the PVC, as you can see there, using some sealant. And this will give us this result for our hulls. The hull in this image shows the lids being attached to the actual pieces, with each of the hulls being attached to the male and female compartments, which will allow us to run the wires through each of the compartments. When the wire needs to be taken off, each of the cables will be having a bullet connection between them. That way it's able to be detached and reattached with ease, taking about 10 to 15 minutes for the full assembly of the boat. For our calculations and our simulations, we decided to run a CVT analysis on the boat using a free body simulation, using the parameters of 5 meters per second, which equates about 12.7 miles per hour, which is very well into our objective. Our weight of our total boat in this simulation was 28.6 pounds, distributing the weight between the frame as well as the hulls, with the volume being about 800 cubic inches. And what we see in these simulations, we actually see the velocity of the boat being displaced around the water. And we actually get to see what the water line would look like from the simulation. The simulation resulted to about having a 50% water line coverage with a reserve buoyancy of 44%. This allows us to carry up to a second boat on top of the first one, which is well enough into our limits. So now I'll pass it off to my partner, Monica, to speak of the frame.
Here you can see the creative frame for the USB. It is made out of PVC, which makes it a lot lighter. You can see in the picture or in the screen that the frame is color scheme and number scheme. That way the assembler can, colorblind or not, can easily assemble it, distinguish it, and be able to know which parts goes together and which ones do not. These sections or this frame are made out of 8 different parts. That way we can run wires through them and connect the USB as well. Likewise, when you put the frame on top of the boat, it will be easier to actually assemble it and disassemble it and put together the wires that run the USB. This frame was made to be easy to transport and easy to carry from one place to another without any difficulty. Even if the customer wants to change the dimensions and wants to make it larger or smaller, this frame is totally interchangeable. These are the main components that we use for the new and improved USB. Obviously, more materials were used in the creation of this boat, but these were crucial ones for the creation of the USB. The boat is made out of a 3D printed composite from PLA, which was then coated with Flex Seal to make it waterproof. Then we have to put latches in every section of the piece to put tension and force to put the vessel together. Then we use foam tape, which the strips were placed in between the pieces in order to help the Flex Seal and the latches to keep the water out of the boat. As previously said, the frame was made out of PVC pipes. We have the controller to control the boat, 2 BESCs, and 2 of the motors. Here's a wire diagram, which is quite simple. It's a parallel connection, and the reason for a parallel connection is for a double battery life. You can see that on the right side of the hull of the boat, we have to use a 3-way connection to connect the battery, run it through the frame, and connect it to the other battery to avoid any wiring shorts. Then we have to use 2 3-way connections to connect on the right side of the hull also the battery to one of the BESCs, then run it through the frame and pass it to the other BESC, while both of the BESCs are connected to their respective motor. Then we have to use a PPM cable to connect the flight controller to both of the BESCs, and that's why we are able to manually control the boat with our control, while the garage door receiver is connected to the battery and to the linear actuator to make it functional. Here you can see a fully assembled USB. As well, you can see it right here in front of us. The frame is placed on top of the boat. We have a square in the middle of the frame. That way we can put the linear actuator on it. You can grab the sampler mechanism, put it on top of the linear actuator. And as previously Bailey said, we're gonna put it in the water, and with the door receiver control, we're gonna lower the linear actuator. And as soon as the sensor of the sampler touches the water, it will pick up the sample oil, it will pick it up, and it will complete the task with no problems.
So we were able to achieve our objectives and optimize the previous USV by making it portable, lighter, and easy to assemble and disassemble. So a major difference is the weight reduction. So the previous USV was 55 pounds and ours is 30 pounds, which is a 25-pound difference. Ours, dimension-wise, is 30% smaller in size. We were able to achieve this because we 3D printed everything rather than using the laser cut wood. We also designed the frame where it's easy for the user to assemble and disassemble, and everything fits in a 30 by 20 by 15 container so that it creates that portable functionality. And the 3D printed parts is PLA filament, so you can easily purchase that or replace any parts if you need to, so like the PVC pipe, where you can get that at Home Depot or Lowe's or anything like that. And lastly, we reduced the manufacturing costs by $2,000, which is a 70% decrease. So here we have is the packaging. If we were to ship everything out, the holes would be placed on the bottom. The frame pieces would be placed along the edges, and with the longer pieces placed diagonally, and the sampler on top. We would also carefully wrap all the electrical components with bubble wrap and place packing peanuts in between the layers to protect the box from any outside sources. And this also passes airline check-in baggage checks. So the reason why I'm showing you this is because we were supposed to ship this out to California to an oil test site with our client, Dr. Garcia, who works closely with the U.S. Coast Guard. But unfortunately, that expedition was delayed due to weather, so that was delayed to July. So that's why, just to show you theoretically, we can ship this off. So here we have is the cost. This excludes miscellaneous and overhead type costs, the sealant, tape, the screws, budget, equipment costs, things like that. So majority of everything is resulted from the motors, the batteries, and the BSCs. The rest were under $20. So in total, everything came out to $842.24. So we weren't perfect. So we did encounter some problems, but we did fix them. So the major issue was the printing issues. We had to test out different printers, and that took a long time because we had many misprints with testing out the test pieces and the final pieces. We had some issues dimensioning with the frame because we did start from scratch, and the way we wanted to design it was the spacing between the holes, and we wanted make it easy for the user to assemble everything. We had some electrical issues, especially with the GPS lock, we could not work on it unless we were 30 feet away from a building. And then we had some issues with the binding the receiver to the transmitter. So this caused us to rely on the previous electrical system. And then lastly, during testing, we did have some water seeping through the front part of the hole, but this was due to our lids. So after adjusting the lids and reprinting them and adding a sealant, a foam tape for a more tighter fit, we were able to fix this issue. So yes, we did have our problems, but we were able to still manage to stay on time and finish the boat as you see in front of us. So now I'm going to pass it off to Edgar.
So as everybody knows, we have learned a lot from this experience in our series design project. The last 2 semesters have been pretty challenging with, we had several challenges, including the programming. We had to use VestTool and INAV in order to get the electrical system working. There was also a lot of 3D printing details that we didn't account for, like tolerances, the stuff that was out of our hands that caused us to be a little bit delayed in the process. Also, we learned a lot about project management. We stayed on task a lot, even though we had the misprints that did delay us a bit. We managed to pull off and finish the project and actually have it working and testing on the pool. So for the future work, this will be more like suggestions that we would make if another future design team, senior design team were to continue this project or even make some edits to it. We would suggest some edits in the 3D printed parts. Of course, we would like to, or would suggest to make the pieces a little bit taller for the waterline. This would also allow the latches to be a little bit higher in the design, allowing it to, just for the waterlining purpose, just to not get the latches just cross with the water and the seawater. Also, the male and female part, the tolerances with the printers really made us kind of delayed, and we had to readjust that by sanding on the male and female parts of the design. Also, the lids provide to be a little bit challenging. It's also because of the 3D printing. The pieces were too large in some cases and we're printing in different ways with regards to the rest. Also, something else we would suggest is make deeper research in regards to the electrical components. This made us a little bit behind the schedule. Also, we had to research a lot about 3D printing. We actually had mentors for that and electrical components. We got a little bit of help. Something else that we would suggest is maybe think about alternative designs. Maybe designs that are compressible or collapsible. Compressible will be kind of like inflatable or something that can compress on itself, or collapsible, which could be folded in this design, make it easier to transport and save space whenever you were able to send it off to somewhere or other places. So the final testing videos. The first video on the left would be the USB testing in the water. We actually managed to test it in the pool. You see how the water line is on the bottom half of the design, and you see how it travels smoothly through the water and just going forward and actually spins. Second video would be the testing of the linear actuator. We had to add that to the electrical design and components. So we actually got it working. You see how it lowers and raises up, which would be the simulation. What would happen in the oil test? Okay, this will be the acknowledged. So we would like to thank the College of Engineering, Dr. Qualley for his advising this project, Mr. Grady for his support during this project. Also, the two, I guess, mentors that we had with this project would be Joe Gonzalez and Mike Tran. They helped us with both the 3D printing parts and the electrical components in order to complete this project. We'd also like to thank Dr. Garcia and his company Water Mapping for providing the practical knowledge and the sampler for us to complete this project. Also, for I guess he did provide for us the possible field testing opportunity, but that couldn't happen due to weather issues up in California. Last, we'd like to thank the Texas General Land Office Oil Spill Program and Canada Multiple Partner Research Initiative for providing the funds to in order to make us able to finish this project. So this will be our references. And also I'd like to mention that there is a sixth team member that couldn't make it with us today due to his athletic, I guess, extracurricular activities. So that'll be it for today.
Who was that?
Sean Gibb.
Sean Go.
Sean Gibb.
Any
That'll be
questions?
it. Any questions?
No. 1 minute, Mark.
So we'll open it up to the judges for questions. Go ahead.
So I'm assuming that the first design, kind of the one piece.
Oh.
Was, I'm gonna assume that it was meant to avoid getting, or the more pieces that you have, the more higher risk you have of leakage
Right.
to the gate.
Yes.
But, so this is for oil, majority tends to be in seawater.
Yes,
So you have saltwater, corrosion, and the way your video showed us, your connections are gonna be somewhat underwater.
Mhm.
So, did you guys, take that into consideration when you were, designing the connections?
we did take that into consideration. That's why some parts of the actual latches are actually also covered in a clear sealant as well. So there is some protective cover on that as well. However, this also allows us to explain that we can reassemble these pieces. These individual pieces can be interchanged with new ones. So it just allows for easy assembly and also easy replaceability with a low cost.
So I guess I have kind of a two-part question, because number one, where you mentioned you had issues with the 3D printing. Was that primarily mechanical failure with the printer itself, or was it a function of tolerance stack up that you had due to the different parts you had? And then part two is, I see you have four different pieces of your hull. Would it be simpler and potentially reduce the amount of problems that you have if you maybe consolidated that down into two pieces while fitting within scope?
Yes, I guess for the first part, we did use a lot of different printers. All the printers printed differently, surprisingly. Even though we had the assembly files in SolidWorks and they look like they fit in SolidWorks, the printers are pretty different, the nozzle size, the bed height, just how it prints in general. So it was kind of hard to go around and like actually adjust them on SolidWorks without knowing the tolerances. So it was a lot of trial and error with the printing. I don't think we mentioned this, but we ended up using around 14 PLA spools of 1 kilogram, but only in that is like 6. So we did a lot of misprints due to the printers, I guess, differences and tolerances. And the second question was the one with the just increase, like instead of 4 pieces, 2 pieces.
Yeah,
Right?
instead of because it sounds like part of it was a dimensional stack up problem.
Mhm.
So if you reduce the overall number of components, would it still fit within the scope and help reduce some of those misprints problems that you encounter?
I would say yes, it could still fit in the scope, because even if we cut it into 2 pieces, we could still fit it. So the scope of it, the idea of it is be easily transportable. As you can see, the boxes right there, and yes, if you put it into 2 pieces itself, it would actually give you maybe even a little bit more room if you just stood those straight up in the actual container itself. It'll give you more room to actually place other stuff in the box with it, and maybe even make it more secure whenever you're transporting it. So I believe, yes, it will stay still in the scope if you do 2-piece holes.
Also, just to mention, we had to work with the printers that we had in school. So actually,
Yeah.
those pieces are like 8.
Resource.
Yeah, the pieces, each piece is like 9 inches, and that's exactly the bed, what do you call it? The bed length of the printers we had available.
So those are.
So we
max-
kind of had to make it like our original design was around like 11 inches. I think
11
long,
inches.
we had to reduce it to,
Make them-
yeah, we wanted to make them longer, and we just had to deal with what were available.
Is there any particular person that kind of helped you with that? You might want to really shout out the guy's name.
No, the acknowledgement.
No, I'm talking about me.
Joe. Yeah, it was pretty much available for the whole process.
Yeah,
To me, that's even more impressive that you had a limitation like that and you're able to still overcome it.
Yeah.
It was kind
That's-
of.
That's thinking outside the box. It was,
It's kind of the same thing with the latches. As you can see, they're very simple latches.
Mhm.
They might corrode a little bit, like Joaquin said, we did put sealant over them.
Yeah.
But if we had industrial grade latches that were easy accessible to us, it may even create an even better seal where we wouldn't even have to worry about that. So, I mean, it's just kind of with the due to the limited resources that we were given from around the school. And so,
So,
And I think that's the key is the ability to work with what you have, because sometimes I think we've been in situations where
Yeah.
we don't have the luxury or the time or the resources cost.
Mhm.
So, with your limitations, you were still able to keep pushing forward, and create what this is, so.
yes, just a huge emphasis that it's supposed to be easy to replace and low cost to remake.
Yeah.
So that's kind of like the main purpose of this
Yeah,
project.
because you went from 55 pounds to 30 pounds.
Yes,
Yes.
Yes.
And then you cut
And-
your cost.
and we cut the length.
Out of it, so.
The length of the other boat was around over 4.5 feet. This is like less than 2 feet or
Yes.
lengthwise. So we did end up making it pretty much easy to transport, and we can literally just take it to whenever you go. Or Dr. Garcia in this case can easily like check in like a normal bag
like,
basically
actually,
in the
you can
airport.
Check it in and then ship it.
Yeah, it fits within those parameters. So it's pretty good, I would say.
Yes.
You have a question?
Yeah, I'd like to know what kind of considerations you had with the size of the boat and the motors versus it going into the ocean where there's currents and waves and other, like, is it gonna be navigable in those waters, or is there a limitation to what the waters are like for deployment?
Well, we would need somewhat of a clear condition to run the sampling mechanism. Actually, the main reason of why the trial was pushed back is because of the harsh weather conditions. So the sampling is already going to take place in somewhat ideal conditions. Now, of course, we did take into account some sort of factor of safety, which is why we have 44% reserve buoyancy for it.
And have you tested it for capsizing the sample? Does it lock the sample in, or can you lose your sample?
So this is actually, we were taxed this and we're working around the sampler.
Mhm.
So we just got this like around a month ago. And I think it's missing the test tube, but it's supposed to turn around and cap up. So we didn't really like touch that at all.
Yeah.
Or just the rest of the book.
Hopefully it does.
That's the goal.
So if you wanted to simulate kind of what he was talking about reducing the number of your connections in there, you could do that just by doing half of the middle to the front,
Yes.
Yeah, we could, yeah.
So,
So.
something I actually wanted to mention as well is that you can even go the opposite way and have even more pieces in case you wanted to make it bigger. The design is very adaptable to what the customer wants.
So you can, instead of 4 pieces, maybe have 5 or 6. It just really depends on what the needs are, or what else you add to the USB.
Then you can test it in those adverse weather conditions they didn't want to test.
Yes.
What's your customer?
Oh,
Dr. Garcia.
Dr.
Dr.
Garcia.
Garcia.
He's the owner of
Um,
Water Mapping Company.
The water mapping company he's the one that he brought us a sampler, he tested us with our initial supplies, and he gave us like our constraints as well.
You have a customer for one, I suppose, or more.
Yes.
But is there a requirement, should you be concerned about, production cost? Is there a need for 100 of them, 1,000 of them, or 10 of them, or?
That would, it is a little bit unknown on how many we would actually need. The samplers themselves, the one that we received is number 4. So I assume that they would need a general certain amount of them, since there are oil spills every year. Just in general for maintenance, or maybe just to have them in sites that could have potential oil spills, just ready to go.
Yeah, if you could have one of these at each Coast Guard station that's stationed along each one of the coasts, then that would be the quickest way possible, because you find the nearest site, talk to them about it, because obviously they'll probably still go out there and they would already have one on hand to where they can get out there, gather the sample the quickest and the most effective, and then decide which option to actually remove the oil itself from that sample. So it's basically just saving time rather than having to take a tugboat out there that lowers and raises kind of the heavier and bulkier sampler systems that is currently in place.
Which could also damage the tugboat.
Yeah, which could also damage.
Did you consider using O-rings instead of the tape?
The foam tape, you mean?
Yeah, in between the segments.
We did not really consider the O-rings, mostly because we needed something that could malleable and that could be more malleable and adapt to the curvature of the hull. However, it would be nice to have some sort of O-ring design on each of the piece of the male and female pieces, so we will definitely look into it.
Just one former senior design instructor question, just to make sure everybody's clear. So what parts on this right here did you guys not design or build? I know the red sampler, was there anything else?
And the linear actuator.
The linear actuator
actuator.
was the other component. Everything else was made or modified by us.
Yeah, the frame was also designed by us with the PVC pipings.
The propulsion system?
Yes, that was also designed by us. The older project had a different propulsion system running. One of the main differences is that they ran a series connection on the boat, and we're running a parallel connection. So they had a need for more power while we needed more lifetime during our missions.
And like for the linear actuator, they actually had to have a DC converter that actually took 36 volts to actually turn on. And that's because their boat produced too much voltage for the linear actuator. So for us, we had to modify that and wire it up our own way because our batteries were actually compatible with the linear actuator itself. So that's what allowed us to kind of operate it with our boat.
Questions, anybody else? Let's give them a hand.